Hi, I'm David. So for this problem, they give us a function f of x is equal to x times, parentheses, 2 plus x, all of that divided by 2x minus x squared. And they're asking us to find the horizontal asymptote, the vertical asymptote, and the whole if there are any. So the first thing we got to do is to rearrange and reorganize this a bit to make it more clear, and we do that by factoring the bottom. We want the top and the bottom to always be in its most factored form. That makes it a little bit easier for us to find the answers over here. So if we look at the top is already factored, but the bottom is not yet factored. So let me factor this denominator, right? So the top stays the same. It's still x times 2 plus x. But now the bottom of the fraction, we can factor out an x because we have two terms here. We have 2x and we have negative x squared. So we have two terms, and we want to factor out actually a negative x. The reason we want to factor out the negative x is because we don't want the factor inside of the parentheses that we're going to end up getting to be negative, right? So if we factor out the negative x, that makes this positive 2x a negative 2. Right? Because this negative sign flips this sign. By pulling out a negative, this positive 2 becomes a negative, right? And then this x obviously disappears because it goes to the outside of it, right? If we were to go backwards, negative x times 2, it gets us the positive 2x again. Meanwhile, over here, we're pulling out a negative x, so what we're left with is going to be a positive x. And so now once we get here, we're able to see right off the bat that these two x's could cancel out because we have an x on top divided by an x on the bottom, right? And because they cancel out, that creates a hole in the graph, right? It means that at this point, the graph doesn't continue. It is discontinuous at this point. So where is this? Well, this is when x is equal to 0. And the reason for that is, if we recall, the denominator of fractions cannot be equal to 0, right? So this whole thing of negative x times negative 2 plus x, this whole thing can't be equal to 0 because it's in the denominator of a fraction, right? And since there's two factors here, technically, that we're dealing with, we can break them apart. Because if this times this can't be 0, then that means either one of them can't be 0 because of the rule of 0. Anything times 0 is 0. Therefore, this times a 0 can't be 0, and this times a 0 can't be 0. That means both of these can't be equal to 0. So then we can say negative x can't be equal to 0. Well, we can remove the negative sign just by dividing both sides by negative, and 0 divided by negative obviously doesn't do anything because 0 is still 0. So x can't be a 0. That would be the location of one of the holes, right? So this would simplify the whole equation to negative, right? We still have the negative sign here, and then parentheses 2 plus x, all of this over negative 2 plus x. Now notice the negative sign, I could pull that out to the front or keep it in the bottom. It's the same thing either way, right? It doesn't matter. The whole thing is negative either way. I can put this out front or I can keep it in the bottom. I prefer to keep it out front for illustrative purposes. You'll see later why. So now we've proven that this is technically the same thing as this. We've just removed the zeros. So what happens if we plug in a 0, right? If we plug in a 0 in for x, then what we're going to end up getting is 2 plus 0, all of it over negative 2 plus 0. And we still have a negative sign out front. So 2 plus 0 is 0. Negative 2 plus 0 is, 2 plus 0 is 2. Negative 2 plus 0 is negative 2. So this would be equal to 2 over negative 2. And we have a negative sign. Now the two negative signs cancel out and becomes positive. And 2 divided by 2 is 1. So all of this is equal to 1. Meaning we have a hole at 0, 1. That if we were to take 0 and plug it in to this equation, we would get an undefined answer because 0 would be in the denominator, and we can't have a 0 in the denominator because anything times 0 would equal 0, and we can't divide by 0. But if the x wasn't there, if we were to take it out, we would have gotten a 1 in the y. And so that's why 0, 1 would be around here. So we would have an open circle here, meaning the graph is going to pass through this point, but it's not going to actually be at this point. Nothing is actually going to exist here, right? So we're just going to put an open circle to represent this idea of the whole. So now the next step is to, let's look at the vertical asymptotes, right? The vertical asymptote is where this part of the fraction can't be equal to 0. Because remember, like we said earlier, there's two parts here. We have the negative x and we have the negative 2 plus x. So this part by itself also cannot be equal to 0. So we have negative 2 plus x cannot be equal to 0, right? For the same reason, because if this was equal to 0, then it would multiply the x and therefore create a 0 in the denominator, meaning the whole thing would be divided by 0, and we can't divide by 0. So again, this thing also cannot be equal to 0. So if we were to solve for this, well, we add 2 to both sides because we want to isolate the x. We would end up getting x is not equal to 2, right? Or in other words, if we were to plug 2 into here, we would end up getting a 0, right? We can even try it out right now. If we plug 2 here, we would get negative 2 plus 2. Negative 2 plus 2 would be 0, so we would have a fraction where we're dividing by 0. Therefore, this would be undefined, no matter what's on top, no matter the negative sign, right? So this would create a vertical asymptote, meaning that at this point of 2, the graph would never touch it. So why is this a vertical asymptote but not a whole? Well, it's because it never got canceled out, right? Because it didn't get canceled out like we did with the whole, it'll still play a part in the fraction at the end. So that means at 2, we can draw a dotted line. So we can draw a dotted line here at 2. Right? So here we have a vertical asymptote. And then meanwhile, how do we find horizontal asymptote? Well, to find horizontal asymptote, remember, we have to look at the top of the fraction, the bottom of the fraction, where we have the greatest degrees, where we have the biggest term. So on top, we have an x squared here, and here we have an x squared, right? The reason we have an x squared here is if we were to simplify this and distribute this x, these two x's would end up multiplying and get us an x squared. Here we would have an x squared. And whenever they're equal to each other, then all we're doing is taking the coefficients of them and dividing them by each other. So in other words, we just look at the numbers that are in front of the x's. We can also look here. It would be the same thing both ways, because here it's also the same coefficient of just 1. Technically, there's an invisible 1 in front of the x's. And so here, this x has an exponent of 1. Here, this x has an exponent of 1. Because these two x's have the same number of exponents, which is just 1, there's an invisible 1 here, that means we can just look at the coefficients of both of these x's, which is 1 and 1. It would be the same thing even if we looked at the original equation. It would be the same thing, because here we have an x squared and x squared. Both of these also have technically an imaginary 1 in front of them. So either way, we would end up getting a negative 1 if we do 1 divided by 1 plus the negative sign that's still here, right? So that means we have a horizontal asymptote at y is equal to negative 1, because all we did was negative 1 divided by 1, right? That's equal to just negative 1. So where is that? Well, that is here. So here is a horizontal asymptote at negative 1. Now, now we can actually graph it. So roughly the graph is going to look something like this. Right? The reason is, recall that our parent function is actually the reverse of this. The parent function has almost like an L shape here and an L shape here. But because of this negative symbol, because this whole thing could equal a negative here, because we could factor out a negative, everything becomes flipped. Everything is a reflection over the horizontal asymptote. So what normally would have been an L shape here flips over and becomes this upside down L shape. And what would have been an upside down L shape here flips over and becomes this L shape up here. Meanwhile, what are the horizontal and vertical asymptotes? What do they mean? It means that no matter which direction we go, we will never touch these points. That no matter how big or small the numbers go, these lines will always get closer and closer and closer to the asymptotes, but they will never touch. That's the definition of an asymptote. And that is how we solve for the horizontal asymptote, vertical asymptote, and whole for this function. Thank you.